Okay, here's review question 2. Graph of f, we have 3 line segments and a quarter circle of radius 2 shown below. And it's given that g of x is the integral from 1 to x of f of t dt. This is where it's going to be similar to the question from the practice test, but different, because they give you the integral and you're just really basically going to be filling in. So let's see how it works. We need to find those values, g of negative 4, 1, 3, and 4. So g of negative 4, we're plugging into our formula. Wherever we have x, we make it a negative 4. So it's the integral from 1 to negative 4 of f of t dt. We don't like those bounds in that order. We flip it, so we negate the integral. So it's negative integral from negative 4 to 1. And that we get the area from our graph. So from negative 4 to 1. Well, first from negative 4 to negative 2 is a triangle with a base of 2 and a height of 4. So there's our 1/2 of 4 times 2. From negative 2 to 0, we have a quarter circle, so pi over 4 times 2 squared. And then from 0 to 1, we have another triangle with a base of 1 and a height of 2. When we do the math there, that gives us 4 plus pi plus 1, or 5 plus pi, so it's negated, so negative 5 plus pi, or negative 5 minus pi, or if you use your calculator, 3 decimal places. Okay, g of 1, again, plug into our formula, integral from 1 to 1 of f of t dt. When our bounds are the same, the value of the integral is 0. G of 3 going from 1 to 3. So we go back up to our graph. From 1 to 3, we are under the x-axis, so it's a negative, and it's a triangle with a base of 2 and a height of 2. So negative 1/2 of 2 times 2 gives us negative 2 for g of 3. And g of 4, integral from 1 to 4. So we have that triangle under the x-axis from 1 to 3, and then the triangle above the x-axis from 3 to 4. So negative 1/2 of 2 times 2 plus 1/2 of 1 times 2 gives us negative 1. So there are our 4 values for part 1. Using FTC, but a little bit differently because it was defined for us, we didn't have to make up the integral ourselves and use the whole formula. Okay, now from negative 4 to 4, at what values of x does g of x have a relative maxima and a relative minimum, and give a reason. So remember, based on g of x being the integral from 1 to x of f of t dt, that's telling us this graph of f is g prime. That's the other part of the fundamental theorem. If we take the derivative of the left side, we get g prime of x. And when we take the derivative of the right side, when we take the derivative of the integral, you're just left with the integrand, and instead of t, it becomes x. So we say, okay, this is g prime. When we're looking at the graph of g prime, a maximum happens when the graph goes from positive to negative, and a minimum happens when the graph goes from negative to positive. So we have a relative maximum at x equals 1 because g prime changes sign positive to negative, and we have a relative minimum at x equals 3 because g prime changes sign from negative to positive. Okay. Now, go to the other parts. This is just a repeat of our graph and our information. From negative 4 to 4, what are the absolute max and min values of g? And show the work. Well, again, we have to remember absolute max or min happens at endpoints or at relative extrema. So we make a chart. We include our endpoints, negative 4 and 4. And we just said in part B that we have a max at x equals, a relative max at x equals 1 and a relative min at x equals 3. And we had evaluated, coincidentally, negative 4, 1, 3, and 4 in part A. So we see our absolute minimum value is negative 5 minus pi, and the absolute maximum value is 0. Okay. And notice it just says what are the values. We do not need to state the x coordinates. We just want to know the actual values. So that's the answer to our question there. And the negative 5 minus pi, you can use your calculator and put it in decimal form to 3 decimal places. That is acceptable also. Part D, at what values do we have points of inflection? And again, Points of inflection are when our derivative, the graph of our derivative, so remember, even though this is the graph of f, it's really the graph of g prime, and we want to know when does g have points of inflection. Points of inflection of g happen where the graph of g prime has a relative max or a relative min, the graph of g prime. So we see at -2, at 0, and at 2. So our points of inflection are at -2, 0, and 2 because the slope of g prime changes sign, or g prime changes from increasing to decreasing or decreasing to increasing, or g double prime changes sign, different ways of saying the same thing. And then finally, the last part, the integral of the absolute value. When we have our absolute value inside the integral, that means anything that may be negative, like this triangle, for example, gets flipped up, becomes positive. So we have that triangle, that 1/2 of 2 times 2 is a positive, not a -2. And then the other triangle, which is already above the x-axis, is 1/2 of 1 times 2. We add those up and we get 3.